Okay, so today we're going to learn about calculus, and we're going to learn more about implicit differentiation. So we're going to do implicit problem. So the problem will ask differentiate implicitly. Find the equation of the tangent line to the ellipse of x squared plus 2xy plus 4y squared equals 12 at the point of 2, 0. So basically, we got to find what y equals, or dy dx. So they give us x squared plus 2xy plus 4y squared equals 12. So these are the formulas we're going to use. We're going to use the point slope form and then the product rule. Okay, so for this equation we want to solve for y. So all we really need is we need to find slope. How do you find the slope of this? You have to take you differentiate implicitly. So differentiate implicit means dy dx, right? We need to know what dy dx means, right? So basically we're taking the derivative in respect to x. So wherever you see an x, you just leave it alone, but when you see y, you have to add a dy dx. That's what differentiating implicitly means. So okay, so let's start on the left. So what is x squared? So what is the derivative of x squared? 2x. Right, so we want dy, we gotta find out what dy dx. So since this doesn't have a y, we just leave it alone. Okay, so what about this one? We have a 2xy. How do you take the derivative of this? You have to use the product rule. So our f is 2x and our g is y. So here's the product rule. So what is f prime? 2x, right? So what's the derivative of 2x? 2. And then you bring the y because that's our g. So it's 2y plus, and then we have to take g prime. So what is our g? Y. Remember we said that whenever there's a y, you have to put a dy dx. So the derivative of y is just 1, but since it's a y, you have to add that dy dx. Okay. And then don't forget the f, bring down the f, so that's times it by 2x. I'll clean this up later on. So now about this one. Since it's a y, what's the derivative of 4y squared? You take the power rule, so that would be plus 8y. Remember, and since there's a y, you have to add that dy dx. Equals, and then the derivative of constant is just 0. Let's clean this up. So I'm going to clean this up. So I'll bring 2x plus 2y, and then we'll do plus 2x dy dx plus 8y dy dx equals 0. So I want to solve for dy and dx, right? So let's get all the dy's and dx on one side, on the left side, and then and the rest will just move to the right. So let's get rid of this 2x and 2y. So I'll subtract 2x and then subtract 2y from both sides. So that's cancels. So on the left you get 2x dy dx plus 8y dy dx equals, and then don't forget the left side, so you're left with negative 2x minus 2y. Okay, so we're not done. We just gotta solve for dy dx, right? That's our goal. So let's factor out this. What do these two have in common? They have a dy dx, so let's factor it out. I'm going to use bracket because it means everything. So we have 2x plus 8y equals negative 2x minus 2y. So I'm going to divide everything by 2x plus 8y. So I have dy over dx equals negative 2x minus 2y over 2x plus 8y. So let's factor, we can factor out I'm going to take out a negative 2 on the numerator, so it's negative 2, and then you're left with x plus y. And then the denominator, I could take out a 2, right? So that would be x plus 4. Okay, so the 2's gets cancelled, but we still have a negative on top, so we're left with, if we distribute that negative, you get negative x minus y over x plus 4. Okay, so this is our dy dx, but we're not done. We got to find, it says at the point of 2, 1, right? So we call this our x and we call this our y. So we just got to plug it into this equation, and this will give us the tangent, or the tangent, or the slope. This will, if you plug in the x and y, you get slope. So let's plug it in. So we said that our x is 2, so that would be negative 2 minus y, which is 1. And then our x is 2 plus 4. So that's negative 2 minus 1 is negative 3 over 6. And then simplify that, that gives us negative 1 over 2. So this is our m, right? That negative 1/2 is our m. We need to put it in the point slope form, so I think we have everything now. So we just got to plug it in. So I'll put it down here. So y minus y1. Our y1 is the same thing as our point. So this is our x1. This is our y1. So our y1 is 1. Y minus 1 equals, we said our slope is negative 1/2. So negative 1/2. I'm putting it in this equation, right? So negative 1/2 times by x minus x1, which is 2. So let's simplify. So this is negative 1/2 x, and then this is just 2 negatives equals positive, so that's plus 1. And then bring down y minus 1. We got to solve for y because that's the whole point. So I'm going to add 1. Add 1. So our final equation is y equals negative 1/2 x plus 2. That is our final equation. So What we first did was we differentiate in respect to x. So let me so we take the derivative in respect to x. So wherever there's an x, you just leave it alone, and whenever there's a y, you just add a dy dx. And then we had to use the product rule. And then once we found our dy dx, we put in our point, which is 2, 1. So we get a -1, and that is our slope. And then once we found our slope, we could put it in our point slope form of linear equation, and then that's how you get this.